Question 6. The first term of a convergent geometric progression is 10. Convergent geometric progression. These are the ones that have the sum to infinity. Okay. They never end, but as you keep on adding the terms, they will always zero down to one figure. Okay. So those are convergent. They come to one term. The sum of the first 4 terms of the progression is P, and the sum of the first 8 terms of the progression is Q. It is given that Q over P is equal to 17 out of 16. Find the 2 possible values of the sum to infinity. Now, what we are going to do here, of course, we know that sum of the first n terms of a GP is A into 1 minus R power n. That is if R is less than 1, okay? Then 1 minus R. But if R is greater than 1, then we shall have R power n minus 1 over, then the R minus 1, like that, okay? Now, they say that the sum of the first 4 terms. So we shall have A here, then into 1 minus, they said the sum of the first 4 terms of the progression is P, okay? 1 minus, then we have R to the power of 4, then 1 minus R. This one will give us P. Then we also have sum of the first 8 terms of the progression is Q. Okay, then we have A into 1 minus R power 8, then out of 1 minus R, this one will be equal to Q. Okay, now here they gave us Q over P. So what is our Q? Is this one here. So I'll get 1 minus R to the power of 8. This is A, then out of 1 minus R, then we shall divide by the P which is here. That is A into 1 minus R to the power of 4 out of 1 minus R. Then this one will be equal to 17 over 16. 17 over 16. There are errors that are made here. Somebody can think like this. Because this one is Q over P, which is equal to, even this one is a fraction, then they will say that Q is equal to 17 and then P is equal to 16. Then they equate them just like that and they continue. That's an error. Okay. Now from here, of course, we can see that this one can cancel with this. Even this one here can cancel with that. So meaning we are remaining with 1 minus R to the power of 8, then out of 1 minus R to the power of 4, which is equal to 17 out of 16. By cross multiplying here, we shall have 16 minus 16 R to the power of 8, which is equal to 17, then minus 17 R to the power of 4. And then from there, we can rearrange and then we get a quadratic in R power 4. So bring this on this side. We shall then have 16 R power 8, then minus 17 R to the power of 4. Then this 16 subtracted from the 17, we shall get a positive 1. And then this one is equal to 0. Okay. This is a quadratic equation. A quadratic in R power 4. Now, using the quadratic equation, using the calculator, we can simplify this straight away. So we go to equation, that is 5, then 3, we have 16, negative 17, then positive 1. That one will give us a 1, and then 1 over 16. So meaning R power 4 is equal to 16. Then there is also R power 4, which is equal to 1. Remember, you have to show the examiner that you have solved. Okay, so bring this one back. We shall have R. Actually, this one is 1 over 16. Sorry, this one is 1 over 16. So if we have 1 over 16 here, when you cross multiply, you have 16 R power 4. Then you bring this one here. That one will give us a minus 1. And then bring this one here. Of course, it is a minus. So that will be R power 4, then minus 1, which is equal to 0. So R is going to be plus or minus. Remember, even power of a negative is also positive. So we have to put plus or minus here. And then R here will also be plus or minus the fourth root of 1. So this one can give us plus or minus the fourth root of 16, that is a 2, because 2 times 2 times 2 times 2, that one gives us 16. So this one will be a half, and this one will be plus or minus 1. Now, since this one is a convergent series, then you should know that R is within the range of -1 to 1, okay? So for sum to infinity, okay, which actually equals to a out of 1 minus r, we know that r is within this range here, okay? Sometimes they write it as the modulus of r less than 1, okay? This one, when you look at modulus functions in A level, in Pure Mathematics 3, you can know how this one comes to this one here, which I'm not going to pass through, okay? Now, that means when we look at these ones here, we can take our, so here, r cannot be -1, neither can it be 1. That means this one is off. So we are going to take these two values, okay? So we shall say for r, which is equal to 1/2, okay? So what will be the sum to infinity? So sum to infinity is going to be equal to a. What is a? A was given as 10. The first term of the progression was 10. And then our r is 1/2. So we shall have 10, then out of 1 minus 1/2. So 1 minus 1/2 is, of course, 1/2. Then 10 divided by 1/2, that is 20. As simple as that. And then for r, which is equal to -1/2, we can have sum to infinity, which is equal to, again, 10, then 1 minus -1/2. This one will be a plus, right? So that will be 3 over 2. Then this one will somersault. It multiplies with that 10. It becomes 20 over 3. So the two values that we are seeing for sum to infinity are 20 and then 20 over 3.